Testing, 1, 2, 3. Hopefully people can hear me. Go ahead and get things set up. Make sure I can see myself. I can see myself. That's a good sign. Hopefully people will join here in a moment, and we'll get started. I see one person has joined. That's good news. We'll go ahead and start in just a minute or so. As soon as a few more people show up, make sure that everything's working properly. Okay, great. Welcome to the 7th live lecture for the MobileCloud Programming course. What we'll be covering today is basically a walkthrough of the VideoUploadClient application, which demonstrates many techniques that will be very helpful for programming assignment number 3 on the client side. And naturally, I'll also be happy to take any questions that anybody has. And if I'm not able to answer some of the questions, I'll be happy to point them along to Professor White, who's not actually here this morning, but he should be here on Thursday when we do our virtual office hour to walk through the solution to programming assignment number 2. So what we're going to start off with is essentially the video upload client. Let me go ahead and bring that up, and I will share my screen so you can see what we're going to cover. Okay, so if you go to the website at the Google, the GitHub account, you'll find this is the latest and greatest version. We've made a few changes since the version we put out the other day to try to get it to run more portably on different versions of Android. There's some differences between some of the versions of Android as far as how some of these features work, and so we're trying to take that into account in the application. It doesn't really matter if this code changes because it's just provided for your edification. You're not required to use it for programming assignment number 3. You're welcome to use it if you find it useful. If you don't find it useful, then there's no need to worry about it. But I thought that if we walk through it, it might be a little helpful to give you a better perspective on how to solve some parts of programming assignment number 3. Let's take a look at the manifest file. You can see here it's pretty similar to most things. We give access to the camera and access to read and write external storage, which is useful for content providers that you'll have to use eventually. We give permission to use the internet. There's a video list activity, which is used to provide a list of videos that are available on the server. Obviously, when you do your programming assignment number 3, you're not only going to be able to show what's on the server, but you also want to be able to show what's been downloaded to the phone. That's the crucial difference between this application and the actual one that you're doing. And then we also have a service as well. We have a video upload service in this particular case. Now, for assignment number 3, you're probably also going to want a video download service. You don't have to use a service, but if you use a service, it'll make certain things a lot easier. And once you see how to do the video upload service, then doing the video download service should be not a whole lot different than that. And naturally, you can feel free to use any of the other classes that we've discussed over time for doing things like downloading and uploading videos. So you can harvest previous solutions from previous assignments in previous MOOCs. Okay, so that's basically the manifest file. Nothing too surprising there. We have a README file that explains how to run this thing on an Android device connected to a server running the video service or the Android emulator. The device and the emulator are a little different. We're still seeing if we can make this work uniformly for everything. There's some quirks that unfortunately Android has that makes it difficult to have this work perfectly on the emulator and on a real phone. But that's okay. That doesn't really affect how you do assignment number 3 because you don't have to do all these techniques on assignment number 3. If you read the assignment, you'll see that you only have to do a few things, and those, of course, are indeed supported. This basically shows how you would test the app on an Android device. So you get connected with your device in the Android environment. And then there's also discussions about how to test things on the Android emulator, showing how to do things there. Notice that the camera probably won't work on the emulator to record videos. Of course, you can always download videos and get them from the gallery. That's not a problem. You can do that. And that's all you need to do for assignment number 3 if you want. And we're still trying to see if we can make the camera work for the emulator. If anybody's willing to spend some time to get this to work, that would be fantastic to contribute it back. And but otherwise, you can still get things to do cool stuff by just picking videos that are in the gallery that you had downloaded via some other means, like through your web browser. All right, so take a look at the README file. Let's now go take a look at the source code. We've started a new organization scheme of late. This is my never-ending attempt to try to make it easier to understand how these applications are designed. And the way we organize the packages now is directly modeled on the model view presenter pattern. And the model view presenter pattern, which we've talked about, which you can read about on the web if you Google model view presenter, or even better, Google model view presenter Android, you'll find a whole bunch of good stuff talking about the model view presenter pattern. And that's exactly what we use as the overall architecture for all of our applications. And this way of doing things just makes it more clear how that works. So here's the view. The view contains a video list activity and a couple of UI components. Start by taking a look at the video list activity. The video list activity basically implements the generic activity framework. We've used this throughout the course. I've actually got a brand new cool version of the generic activity framework, which I didn't integrate into here yet just to avoid adding one more thing to have to learn, but it's much cooler now, and it decouples the presenter from the activity used in the view. And so we might talk about that at some later point. We'll certainly cover that in the next time we run these MOOCs. So video list activity is a generic activity, and video ops is the presenter. That's the guy that does the business logic. And this also implements the upload video dialog fragment, and there's an audio video selected listener, which is used to actually select a video for uploading. We're going to be using this activity to launch a couple of other activities to either record and or select a video from the gallery. And so these codes are used to indicate what commands we're sending to run other activities. We have the request video capture and the request get video. Those are 2 requests. We'll show you how that works in a second. We use a broadcast receiver that registers itself to receive a result from the upload video service when a video upload completes. And so when the video completes, we'll find out whether it succeeded or failed. And we also have a really cool GUI widget called a floating action button, which basically allows you to upload a video when a user clicks on it. The real neat thing that we've added to this example that you're welcome to use or not. Here's the onCreateHook method. This does the usual sets of things. It sets the content view. It sets the register receiver, so we're going to receive notifications when the service is done uploading a video. We create the cool floating action button, and then we call up to the onCreate method of generic activity, passing in the video ops class to instantiate and manage. So that's where the business logic goes. Here's the broadcast receiver. This is going to be used when it's going to get called back when the upload service has uploaded the video, and what it'll do when it gets called back is it goes out to the video service and it gets the list of videos that are now available at the video service. So that's what it's going to do there. It's kind of what's called trap-based polling. You wait till you're notified, and then you go ahead and pull the results. Here's the register receiver method. As you can see, it creates an instance of upload result receiver, and it creates an intent filter that's going to filter on this particular response. And then we go ahead and we register the broadcast receiver so that it'll get called back when we do a send broadcast. And that's actually done in the service later. We'll talk about that. On destroy, when it gets called, we unregister the broadcast receiver so that it won't listen anymore. We could probably This is probably good. We could also potentially do this in something like on pause or on stop as well. Here's on video selected. This is the option that the user selects to indicate what action they want to use to get a video to upload. And the choices, of course, are to either get a video from the video gallery or go ahead and record a video. So those are the two different things you can do. We probably need to have another case here as well, which is going to pop a toast and say, hey, what are you doing? You can't support that option. Here's the factory method. So this is basically a factory method that's used to start an activity by an implicit intent. And you can see what it does here. I've got to take it back. It's not really a factory method. It just goes ahead and creates an intent that's going to get content, and it's going to go ahead and look in the gallery. It's going to look for these types, any type of video. And if we find such an intent, or such an intent is supported, we go ahead and start the activity for result, passing in this request code, request get video. We can use that in a second in the on activity result method. Here's on select record video. If you've got a device or an emulator that will do recording properly, then this will go ahead and create an intent that will start up the camera, the video camera, and it'll let you go ahead and record that. When either of these things are done, then the path of the code comes to the on activity result method. And what this does is it checks to see if things succeeded or failed. If it succeeds, then it goes ahead and gets the data. And if it was a request video capture activity that's did the work, then we go ahead and get the video via this means. If it was the recorded video that we got from, I'm sorry, the gallery video, then we use something called gallery utils in order to get the video ID. And in both cases, we end up with a video ID. We pop a toast saying we're uploading the video, and then we go ahead and upload the video to the video service. If for some reason the video didn't get downloaded, or we couldn't get a video that we wanted in the first place, we pop a toast to tell that. Here's the floating action button. This is some interesting stuff that you can use to make a floating action button in Android. I'm not going to walk through all this code in detail, but it basically is something you can use if you would like to do these kinds of material design like user interface widgets. And then there's a couple of options, menu management stuff here. Okay, so that's basically the video list activity. Here's some of the other UI stuff. Here's the floating action button that's based on Google's material design principles. Again, I'm not going to go through all this code in detail. It's just GUI magic, and you're welcome to leverage it and modify it as you see fit. There's an upload video dialog fragment that shows the user a dialog that has a list of options for different ways to get the video. To upload. So you'll see that the options are using the video gallery or recording the video. And these are the options that are presented to the user. And it's a fragment, so it's got various lifecycle methods that get called. And this basically goes ahead and creates a dialog menu that gives the user those options. Then there's also a video adapter. And the video adapter basically is used to display the videos that are available. And it does it using an adapter-like model. And so it'll print out the list of the videos, and you can then get videos from the list by basically pressing them, and so on. So there's a couple things you can do with the video adapter. Again, that's just sort of GUI stuff. I'm not going to go through that in detail. That's the view portion. That's the part that interacts with the user. And there's various ways of doing model view presenter. In one model, the view is totally passive and it forwards everything to the presenter. In other ways of doing the model view presenter pattern, the view is more of a supervisor and it does some of the work on its own. As you can see, we kind of use the supervisor model here, where the view does some things, but then it calls up to the presenter logic or out to the presenter logic to do the actual business logic. If you look at the presenter, which is kind of the middle tier guy in this model view presenter architecture, the middleman as they call it, or the middle person, we have a video ops implementation, and this manages all the video related operations, and it implements the configurable ops interface so it can be managed by the generic activity framework, and it also implements or extends the generic async task ops, so its do in background method could run in the background task, and that's basically used to do the various work that's going to take a while to run. So we have a weak reference back to the activity. The new framework that I've got for generic activity doesn't have a reference to the activity in the ops class. It just has a weak reference to a view, which is basically an interface, so you don't have as tight coupling on the activity, which is cool, but we won't talk about that right now. We have our generic async task, which is used to do the basically the long-running operations in the background, and we'll talk more about that in a second. We have something called a video controller that mediates the communication between the local Android storage on the Android device and also between the video service, which is running on the server, of course. That's going to use retrofit to do its thing. We have a list of the videos that are available from the video service. So if you need to get that list, you can do that. Here's the adapter that displays that. We need a default constructor for the generic activity framework. Here's the virtual constructor on configuration. And it basically sets the weak reference so we can have garbage collection work properly. It gets the list of videos, and then the list view for displaying a list of videos. And then the first time in, it goes ahead and creates the video controller, and it goes ahead and creates an adapter for this so you can see it. And then we go ahead and populate the list of videos from the server. Now, this example here only goes back to the server the first time. You could always change that if you wanted to, of course. You could move this code here out of the first time in flag if you wanted to do this every time a rotation occurred. That's certainly something you're welcome to do. This is actually sort of an incomplete version of a complete version of assignment 3, so we didn't do that here. There's no necessary reason to contact the server every time that the orientation changes. In real life, you would more likely keep a cache of videos stored locally and accessed by a content provider that you would make, and so that would be where you get the actual information to display on a regular basis. All right, so that all gets done the first time in and other various points. And here's how we display the video list. So if we've gotten a list of videos, then assuming we have a list of videos to display, we set the adapter to display those videos, and we pop up a toast that says that this is the videos that are downloaded. I would probably say videos available from the video service. And if you didn't get a video, then you need to connect to the video service, and we shut things down. So we're going to close down the activity. Here's how we get the video list. We come in here and we go ahead and execute the generic task, and that will then go ahead and create a background task. We execute it, and of course generic async task is actually an adapter, and you'll see in a second how it works. That will end up calling the do in background hook method right here, which will then talk to the video controller to get the list of videos from the server and then go ahead and display them. And here's the upload video. So I guess I could put this up here just for kicks. Let's go ahead and make this here. So this is the upload video method, and the upload video method, as you can see, goes ahead and sends a command to the start service. It creates an intent that will start up a service, which is actually implemented using an intent service. So this goes ahead and sends a command, an intent command, to the upload video service. and that upload video service will then go ahead and upload the video, and that runs in the background using the intent service, so it can afford to block. And so you can see that we're going to upload a particular video with a particular ID, and its content is located at this URI, and that's going to get uploaded to the server, or the video service. Okay, so do in background runs in the background, of course, because getting a list of videos is going to be potentially a blocking call, or will be a blocking call, and so we don't want to block the main thread, so we run that in a background thread. Of course, you could also use retrofit using the asynchronous model of invocation, and the various examples that we have, like the weather service provider and some other examples, the acronym response cache example, those illustrate how to use asynchronous retrofit calls. We didn't use them here just because we didn't want to get it more complicated than it needs to be, but you could always do that, of course. All right, so that's the presenter. And then here is the model. So the model, of course, is the part that either deals with data that's stored locally, which is what's in the provider part here, or it deals with data that resides remotely, which is what the web data part is, which is the part that talks using retrofit, or it's a service that's used to interact with a server somewhere relating to managing data. In this case, in this particular case, uploading videos. So let's go ahead and take a look at this. So we'll start with the service first. So upload video service runs as a started service, actually runs as an intent service, and its purpose is to upload a video, and then it goes ahead and sends a result back to the video list activity by using a broadcast. Here's the particular custom action, which is used for the intent that we're going to have here. We have a key that's stored as an extra in the intent to indicate the ID of the video that we're uploading. And the default ID, if there's no ID present, then this is the one that's going to be used. We also use Notification Manager to send notifications to the notification bar on the phone, indicating the progress of the upload. So you can kind of watch the progress from your notification bar on your phone. We have a video controller that's actually used to talk between the video service and the local storage in the Android device, whatever it is. Here's the Notification Manager. Here's a builder that's used for the notification. Here's the constructor. As you can see here, this thing is an intent service, so it needs to call up to the superclass. And we have a couple different formats for the constructor here. Here's the factory method that makes an intent. As you can see, it goes ahead and makes an intent that will start, it makes an explicit intent. Actually, this is not an implicit intent, this is an explicit intent. And because you should use explicit intents for services, and it goes ahead and makes an explicit intent, puts the video key in there, and sets the data, which is the URI where the video is actually stored, the video that's going to be uploaded. And then when start service is called, on-handle intent gets called back by the intent service, and it starts a notification. Let's take a look at start notification. The start notification basically uses the notification manager in order to create a notification that will tell the video is in progress, and we'll have a small little progress icon that's used to indicate how it's going, and that goes into the notification bar. We then go ahead and get a video controller, which we're going to use to actually communicate with the server. We get the video ID from the intent extras, and then we tell the controller to start uploading the video. It's perfectly fine for this thing to block because it's running as a background in a background thread in the intent service. And after upload video returns, we either succeeded or we failed, and we call, in either case, we call finish notification. We'll look at that in a second. And then we call send broadcast, and send broadcast just goes ahead and informs the activity, which is the let's see, the activity video list activity, that the video upload is complete, so it can update itself. That's where that gets done, as a send broadcast. Here's finish notification. This just goes ahead and will finish the notification to indicate success or failure using the various mechanisms in the notification manager of Android. So that's the service, pretty straightforward. You could imagine doing something like that for assignment number 3, or you can imagine writing your own way of doing this if you so feel like you'd like to do it yourself. And of course, then a download service is going to be probably very similar to the upload service, just going in the other direction. Here's the web data package. This basically is just the interface to the video service web service. That's what you're implementing for assignment number 2. And that basically just provides a bunch of ways to talk to the service. Obviously, you could have more methods here to talk and do more things with the service. This is just a subset that's needed to upload stuff. So we have various parameters that are going to be passed in various ways for the requests, like the path that'll be used to talk to the video service. And then we've got a bunch of methods. These, of course, are retrofit enabled through annotations. So we are going to go to this video, this URL that we provide up here, and we have a way of getting a list of videos from the service. This will give back the list of videos it supports. We can upload a video to the service, and it'll give us back some metadata. And the metadata that comes back tells you some more information that you can use to do other things with the service. It gives it an ID for example. So here's a set video data. So we can basically add a video. We can also add the data. And you can see this is a multi-part method that's going to be used for that. And it sends up the video data. And then we also have get data, which we can use to access data from the server, from the video service. And I don't know if let's see, but we might use that in this example, but it would certainly be something that you could use for the assignment number 3. So this is how you would actually stream the results at the video service back to the client. Here's the provider. Now this provider is a simpler provider than you'll need for assignment number 3. This provider basically is more or less a front end to the Android media store. So Android has this thing that's called the media store, which is a content provider that it uses to store video and audio that's captured on the device. And so this is basically just sort of a facade class. I guess that's a good name for it. It's a facade class or facade that defines methods. So here's some of the things you can do. You can use this facade to query the Android content provider for the media store, which you get through this URI. And you can use this in order to go ahead and get a video, get the metadata for a video by its ID. So if you have an ID to a video, you can go and query this thing. And assuming that there was something at the query, you go ahead and get the metadata via this get video method we'll look at in a second, this helper method. There's also a way to get the file path to where the video is actually stored. And this involves taking the title of the video and creating a where clause, and then querying the content resolver at the external content URI with the selection clause with the video title. And if you get back what you want, then it goes ahead and gets the file path from here. And then here's another helper method that gets the video data, the metadata from a given cursor for a video. So assuming you've gotten the video by the video ID, it goes ahead and looks up and gets the display name out of the cursor, the duration of the video out of the cursor, and the MIME type of the video out of the cursor. And then it goes ahead and returns a new video metadata object that contains those pieces of information. Notice that it doesn't have the ID or the data URL of the video yet. And that's, of course, because it's the job of the video service to generate these particular fields. Those fields need to be generated by the video service. And we'll see when we use retrofit, we get that back as a result from the two-way call to the service, the video service. Here's the POJO that represents the metadata of interest. So this is really about the metadata of the information about a video. So we have things like its ID, its title, its duration, its content type. There's also some stuff we put here to ignore certain things, to exclude a member, a field from serialization and deserialization. We're not going to set that with this mechanism. We'll set it a different way. Here's the constructor that we use to initialize those various fields. And then the other stuff are just setters and getters to get the various pieces of information here. And then there's a way to do some comparisons if you want to put this in a hash map or something like that. Here's video status. This basically just keeps track of metadata of interest that relates to the data that's downloaded from the video web service, whether it's what state it's in, whether it's ready, whether it's processing, and so on and so forth. That's used by some of the other parts of the code. And then here's the video controller. And the video controller is, again, basically a mediator that interacts between the video service and local storage on the Android device. So you can see it keeps track of the Android video cache that we just talked about. It keeps track of the proxy to the video service, and its constructor gets the cache, builds the proxy to the service using the crazy retrofit API syntax here to get an endpoint to the URL, and then give it a factory class to make the video service proxy instance, which is what we're going to use to the code. And then we have various methods in here that actually do the work of communicating with the service. So upload video takes a video ID and a video URL, which are local on the device. And of course, you know you have those things because you either recorded a video or you got it from the gallery. Either way, we get the video metadata. And assuming we actually got something, we go ahead and add that video to the video service. And notice that's a two-way call. So the video controller always has to run in the background using, say, an async task or using an intent service. It adds the video, and then it gets back some additional metadata. And that additional metadata indicates other information that we're going to use when things came back. And once we have uploaded basically the metadata, then we go ahead and we are going to upload the actual contents of the video. And we have a particular constraint here that we don't want to have more than 50 megabytes uploaded. Obviously, you could change that if you want. We just wanted to keep things manageable so that we don't break the web by everybody testing their programs through a real server. So if the amount of data to be uploaded is less than the size, we go ahead and we set the video data, and we get the ID, which this is the ID that came back from retrofit from the video service, and we get the content type that came back from the video service, and then we take the video file. That's the file that's going to be uploaded, and so that actually goes ahead and gets uploaded then to the service. And we see if we succeed or failed. We need to show a toast if things go wrong. These are some extensions we're going to add. And then here's, of course, the way we get the videos from the server. So this will go ahead and get the video list from the video server, video service, and that comes back as an array list, and we return it as a list. And so that's how you get this thing returned. That's basically the provider part, the sort of the model part, if you will. And then the only other thing left here to talk about are some of the utils. These are things that are sort of shared and helpful. There's a set of constants here that we use for the video service, how to access it, the URL for it. Take a look at the README file to figure out how to set this to something that makes sense for your deployment. This is the maximum size of the video to be uploaded. So it's basically 50 megabytes, as it turns out. Here's the video storage utils. This is actually not really needed for this assignment or for this example. This is actually useful more for your third programming assignment, because this gives you a way of being able to store video locally in your file system. And so this is basically a way to store video content that you might download when you do the download operation. So I'm not going to go through that right now, although this is something you might take a look at for your solution, because it'll give you a way of being able to store videos that are downloaded from the video service, in the right place. And the only other thing here that's worth going through is video gallery utils. And these are a set of things that we added very recently to work around some defects in different versions of Android. So different versions of Android behave differently, unfortunately. I wish that wasn't the case, but it is the case. And so this application tries to make it easier to do things like access the video ID of a URI based on some information about how the URI is formatted. And so you can take a look here. This is code that you can either look at carefully and try to digest, or just take it for granted that it works properly, and then you can go ahead and figure out how to make it work for you. Here's a way to get a file path from a URI. This is basically splitting things up in different ways based on what version of Android you're actually working with. And I wish it wasn't the case that it was like this. I wish Android worked in a consistent way, but we all know that that's just life. When you're writing software these days, you have to work around different versions in your software, and so that's just sort of the cost of doing business, if you will. Okay, so these are basically just utility operations, and we continue to improve them. If people have other suggestions on how to make this stuff better so it's easier to use, that's fantastic, but I wouldn't worry too much about how the code here is actually implemented. It's just something that you can use to make your life a little bit easier when you're implementing your solution. Okay, so I think that is basically it for the examples. If there's anything else here we haven't talked about. This is the common directory. We've talked about all these classes before in various points. We got generic activity class, which is used to instantiate the presenter objects for the business logic. We got the generic async task and generic async task ops, which are used as adapters to hoist the do in background and on post execute methods into the class we want to allow to run concurrently. We have the retain fragment manager that's used by the generic activity framework to persist the state of the ops objects, and so on and so forth. So there's nothing really there that we haven't talked about before. Okay, so that's a quick overview of the example. Hopefully you're able to download and build that example and run it. Make sure you read the README file before you do that. It'll give you a lot of hints about how to make it work properly. And of course, if you see things that can be improved, please let us know. We're always happy to improve this. And again, if you feel like you'd like to use this as part of your solution, that's great. If you feel like you don't want to use it as part of your solution for assignment of 3, that's fine too. Just trying to give you some more hints about how everything works. Let's see, is it safe to store context instead of activity in our classes? We should probably use weak references for contexts. Yeah, that's probably a good idea. We'll go back and take a look at that. Let me make a note of that. That's a very good suggestion. We'll put a note there. We'll go back and fix all those kinds of things. This particular example needs to be fully integrated with our latest, greatest way of doing everything. We just haven't had time to get it working and do all the massaging to make that stuff work. Video controller doesn't have an annotation like @controller. I'm not quite sure if that's important or not. I will make a note, however, and we will take a look and see whether we need an annotation here. All right. Can we get away in assignment number 3 with a provider like the example and not a real provider? No, you cannot do that, because the provider that's used in the example here is the Android content provider, which is really just used to store the content of videos that were captured on the device using something like the camera, the video camera. It's not meant to be a general purpose provider, and in fact, it's missing a bunch of important fields that you would need in order to do things properly for assignment number 3. For example, it doesn't keep track of the stars, the star ratings. It doesn't keep track of the data URL that you need. It doesn't keep track of the video ID that's uploaded in the server, in the video service. Because of course, the Android media store content provider knows nothing whatsoever about the URL that's stored at the service. It doesn't know anything about the video ID that's stored at the service. It doesn't know anything about the star ratings that's stored at the service. So you can't use a single provider. You'll have to use your own content provider. And you're welcome to do that any way you'd like. You can either create a content provider that basically mimics the information in the Android Media Store, or you could try to do a provider that would somehow be able to join with the Android content provider on some key, and so on. You're welcome to do it any way you want. For testing on a device, can we just run our server on the desktop via the home Wi-Fi rather than setting up a hotspot on the device? You're welcome to do it any way that works for you. We'll have instructions for how to run it. I recommend doing things locally. That would be my recommendation, just because the more local it is, the less likely you are to have problems with network failures and so on. But we have instructions on how to run the service, and if you take a look at the README file, it'll explain how to do it, and the peer grading instructions will follow the same model that we have in the README file. Is it possible to see a screencast for assignment 3? Yes, we will definitely be putting together a video showing our solution for assignment number 3, which is super cool, and we'll probably get that done maybe a little bit later this week. But yes, the intent is to have a screencast so you can also see. Naturally, you are under no obligation whatsoever to have your solution look anything like our screencast as long as you fulfill the requirements. So you're welcome to do it different ways, but we wanted to give people at least a model of how to do it. So for those of you who maybe don't have as much background or would like more guidance, there's something you can look at. So that's why we have the video upload client, just so you can see something along these ways. Should all the UI elements in video ops be weak references? Probably so. Let me make a note of that, and we will fix that too. Let's see. Let's see. Weak reference. Yeah, we're still having fun playing around with the design, the model view presenter design pattern, trying to get the right partitioning between view related stuff, which is primarily supposed to go in the view layer and the activity portion, and the part that relates to the presenter portion, which goes in the ops class. And I've been having way too much fun retrofitting all of our existing examples. All the examples that we've covered before have recently been updated to use this cool new framework, which makes the decoupling a lot clearer and less tightly coupled. But we haven't had a chance to go back and retrofit everything. And so the video upload client is the next thing on our list that we'll go back and refactor. So these comments are really helpful. Wouldn't the server be a better place to limit the upload size to 50 megabytes? Well, certainly the server could limit the upload size to 50 megabytes. We were trying to do a bit of a sanity check on the client so people don't start to try to upload large amounts of data and swamp the network only to have the server reject it. So yes, that's I suspect you'd want to have that done both places. Although honestly, a server probably doesn't want to have a 50 megabyte limit. That would be rather small. If YouTube, I mean, basically what we're doing here in a sense is we're kind of creating a little mini YouTube service with a YouTube client, although it's obviously not as cool as YouTube, but it's sort of along the same lines. And YouTube has more than 50 megabyte limit. At least I hope it does, because I upload things much bigger all the time. Do we need to store individual video ratings for each video at the server, or we can just save the average ratings so far? I would just store the average rating so far. I think that would be the most sensible thing to do. Obviously, you are welcome to do it however you'd like. In this particular case, for assignment number 3, we haven't really taught the concept of authenticated accounts yet. So obviously, malicious users could upvote or downvote videos wildly at their heart's content, and we don't guard against that in our current implementation, and that's by design. The topics related to authentication and user accounts are going to be covered in the next MOOC, the MOOC on security, and so we're just providing the starting point here. By the way, for those of you who plan to stick around for the next MOOC, and I hope you do, we will be revisiting this example in the next MOOC, except in the next MOOC, we're going to, of course, add more features. We'll add user accounts, authenticated user accounts using OAuth. We'll also add support for more interesting things like ratings, where you can rate the video and have, in addition to ratings, you have comments about the video like you would on Amazon. And then we're also going to be modifying the client side in the next MOOC to use a sync adapter. So the sync adapter will be used to automatically synchronize the data without having to push things immediately, so it can defer that till later. But yeah, you can do that. I'm a little confused on the download part for assignment 3. Well, for assignment 3, you have to complete and flesh out more of the details than we show in the video upload client. We didn't want to give the whole solution away, so we just gave a portion of it away. So for downloading, what you'll do is, once you know that a video exists on the video service, and how do you know the video exists on the video service? Because you use that list all videos method that we talked about and showed here. So once you know a video exists, then you can go ahead, you'll be able to go ahead and click a button to go ahead and start the download of the video. And the video, of course, will get downloaded, and I recommend using a download service. You don't have to, but I recommend doing a download service. That's a good thing to use at this point, especially if you've taken the other MOOCs, because we've talked about services and so on. And you'll download the contents of the video, and you'll store them locally in the local storage on the Android device, and then you'll update the content provider to include the metadata about the video, like its title and its duration and its star rating and so on. And then, of course, you'll have a path to the video data, which will be stored as a path in your content provider. And then if somebody wants to play a video that's been downloaded, you can just play it directly on your phone. If you'd like to add support for streaming, that's fine. No problem with doing that. That's not actually part of the requirements. This is about uploading and downloading videos and storing them in content providers, because that's really the focus, one of the key themes of this course. So if you want to add support for streaming, that's okay, but that's not the required feature. You have to be able to download the video and store it locally. So hopefully that addresses your confusion. You've already done a whole bunch of work if you've taken the earlier MOOCs on downloading video, so you should have a pretty good idea of how to download the video. And now you just have to put it into the content provider so it can be accessed in a nice and clean way. Which code files are for the server and which are for the clients? Vernon, I don't understand your question. Are you talking about the programming assignment, or are you talking about the example video upload client we just looked like? Because, of course, the video upload client, as you might guess by the word client in the name, is entirely the client side. So the video service, of course, is what you're implementing for assignment number 2. So the purpose of assignment number 3 is to take the solution you did in assignment number 2, add a little bit more to it, the star ratings part, just a little bit more on the server side, and then write a client that actually uses it in an interesting way. So in assignment number 2, of course, we gave you the client as part of the auto grading framework. So you didn't have to write the client code, which is fine for assignment number 2 because we're focusing on the service part. But for assignment number 3, we want you to get experience actually writing a client and actually get experience using content providers, which is what we've also focused on in this class. So I don't really know what you mean by your question, so feel free to re-ask it. For the average ratings, you'd need at least the average and account and the total rating and count so the new average can be calculated. Yes, of course. You are free to do that any way you want. So we're giving you maximal flexibility. It's up to you to decide how you want to do it. We're not going to constrain you one way or the other. When uploading assignment number 3 for pure assignment, should we upload 2 different projects? One Gradle project for the server side and one Android project for the client side. That's probably a good thing to do. I would recommend that. Let's see. Okay. Oh, we're getting close to the end of the questions. That's good. So is the activity elements config changes attribute? Let's see. All right, hold on a second. Let me go take a look. And to answer this question, I'm going to have to pop over and share my screen again. Hopefully you can see the screen. So the question up here had to do with the Android manifest file. All right. So I don't see. Oh, now I think I understand your question. Yeah, this solution here uses the now. Okay, now I understand your question. Sorry, it took me a second to understand what you're asking. So your solution for assignment number 3 should not use the config changes attribute. That's a nasty hack that is really usually more trouble than it's worth unless you have a very, very simple user interface and don't want to be worried about scaling. You don't need to be worried about scaling things and reorienting stuff when you slide the stuff around. So no, I would not. You don't have to use the retain fragment manager, of course. You can do it any old way you want, but you cannot use the config change attribute to just ignore configuration changes. That's kind of a sleazy solution. And at this point in the MOOCs, we've covered handling configuration changes in a ridiculously concise and trivial way over and over and over again. Every single application that we do works exactly the same way, and it's really simple to do it. So you don't have to do it the way we do it, but you should at this point be able to do the handling of this properly and not have to go and use the config changes hack. Why don't I write a book about components and patterns in Android? Well, believe it or not, we're doing that. There's a couple of things going on right now. In fact, I was just talking to the publisher this morning on my way to work. So the next thing that I'm doing, and this will start occurring over the next couple months and probably finish up by the end of the year, is I'm going to create a new live lessons, as opposed to live lecture, a new live lessons course for Pearson, which will appear on Safari to complement my existing courses on Java concurrency and design patterns. That'll be basically the stuff that we cover in the MOOC. So it'll be Android concurrency, Android communication, Android data storage, and lots of patterns. And it'll cover the material we cover here in much more coherent and well-organized way than what we do with live lectures. But it'll also have very detailed walkthroughs of all the code examples and stuff. So that'll be the next thing. And then the other thing that we're doing is to basically go and revise the POSA 2 book. That's the Pattern Oriented Software Architecture Volume 2 book. That's the book that has patterns like active object, half sync, half async, and other stuff we talk about a lot here. We're going to redo that book, and that'll use Android as the focus of everything. So we'll use Android and Java, actually Java and Android, to illustrate all the various things. So that's kind of the next step in the sequence of stuff, is the videos and the book. What about iOS? What about iOS, Oscar? I don't know anything about iOS. I have no time at this point to learn about iOS. There are other people who do iOS. Unfortunately, for things I like to do, which really relate to concurrency, iOS has a pretty, how shall I put this nicely? It basically leaves concurrency as the job for the framework to handle, and applications do little or nothing to actually do concurrency in iOS. So that doesn't sound very interesting to me. The other thing that I absolutely cannot stand Objective-C. I think it's the most hideous looking language I've ever come across. So the idea of trying to learn Objective-C doesn't appeal to me. And there's just not enough time in the day to do the things I have now. Let's see. Java's getting popular in middle and summer camps and so on. Any guidance on material for kids learning Java? So there's a couple of good resources you can find for learning Java online. I don't know if there's a full-blown Coursera MOOC on Java yet, but there are other resources available. I think there's something called Java for Complete Beginners or something like that that's available through Udacity. That's good to start with. I actually have a bunch of videos on, not really for beginners, mind you, but videos on things like Java inheritance, Java dynamic binding, Java generics that are available. on my website. It's part of the CS 251 class. That might be useful. But there should be plenty of stuff out there that you could start with. And teaching Java is really not that hard. If somebody has the patience of learning a little bit more syntax than you would use in Python, then I think you'd be okay. Actually, learning Python is a good place to start also. Let's see. Shouldn't there be best industry practices to have software developers be able to automatically use patterns to do these up downloads as the best companies do? Not really sure what you mean. There are definitely lots of best industry practices. There are lots of frameworks that are basically embodiments of patterns. A framework is basically a code library that supports inversion of control and domain-specific function and structure and functionality, semi-complete applications that are based very heavily on a pattern language or a pattern sequence. So yes, there's lots and lots of stuff that do all those things. So I'm not really sure what you're asking. What we're doing in this course, of course, is we're teaching people how to do various Android features like content providers, like services, like concurrency with tasks, and so on. And we're doing that in the context of example applications. You could probably go out and get a library that does all that stuff for you, right? So there's a neat library that does image loading, where you can basically load images given URLs and load images doing paths. And so if you were doing production work, you might well do that. But that would completely and totally miss the point of this class. And the point of this class is not to teach you how to do a video upload download application. It's to teach you the features of Android and the patterns and frameworks of good programming. And of course, we don't want to make it a boring, mundane, simple set of trivial examples that are really not very interesting. So we choose fun stuff like uploading and downloading videos, playing music, doing other things to access web services, find the weather, right? But those examples, applications are not there because we think that you need to write those things professionally. It's because they provide us a way to talk about the interesting design concepts at scale. And so you get to learn about all the other issues that we focus on so much, about abstracting away from implementation detail, being able to handle screen rotation cleanly, using the model view presenter framework to separate your code concerns. That's the real focus of this stuff. And we're just picking fun examples so you can get a chance to learn this stuff without drowning in a sea of complexity and being bored. I have never read the Head First Design Pattern book, so I don't really have any comment. Again, Vernon, you're really barking up the wrong tree here. We're not reinventing the wheel. We are learning the mechanisms of programming in a way that is accessible to a broad range of people. Yeah, so I'm not really going to go any further on that line of questioning because it's really not relevant to what we're trying to cover here. Okay, well, it looks like that's basically the end of the course, or not the end of the course, the end of the session. If you have any more questions about today's content, please feel free to post them to the discussion forum. And we will undoubtedly be uploading some new and improved versions of the video upload client. But don't feel obligated to track our changes if you don't want to. The stuff that's up there right now should be pretty good as a starting point. Like everything, it of course can be improved. We will continue to improve it. And so this is hopefully going to give you enough information to keep going and moving ahead. Anyway, thanks for joining, and I'll talk to you later.